Well, here's a message from a man who should know. The second man on the moon, Colonel Buzz Aldrin. We can explore the moon and develop the moon. We should go boldly where man has not gone before. Space holds secrets beyond our wildest imagination. But what if some of those mysteries weren't as distant as we thought? What if clues to ancient civilizations were hiding in plain sight, right within our solar system? I saw this illumination that was moving with respect to the stars. We were smart enough to not say, Houston, there's a light out there that's following us. One of humanity's greatest explorers may have uncovered a truth too incredible to ignore. There's a monolith there, a very unusual structure on this little potato-shaped object that goes around Mars once in 7 hours. Join us as we dive into the mysteries of Mars, Phobos, and a revelation that could change everything we think we know about the universe. World's most celebrated man, Buzz Aldrin, one of humanity's most celebrated astronauts, is best known for his role in the historic Apollo 11 mission, which marked humanity's first steps on the moon. But his legacy goes far beyond that iconic moment. One such mystery centers around Phobos, a moon of Mars, and an enigmatic structure on its surface that has sparked curiosity across the globe. Buzz's reaction to this discovery was nothing short of extraordinary, and it made him finally reveal what NASA was hiding for decades. But before we get to that, we must meet the man behind the words. Buzz, born Edwin Eugene Aldrin Jr. on January 20, 1930, in Montclair, New Jersey, grew up in a family that nurtured his love for flight and exploration. His father, a seasoned aviator and a student of aviation pioneer Orville Wright, deeply influenced Buzz's interest in aerospace. His mother, whose maiden name was Moon, added an almost prophetic touch to his destiny. Buzz excelled academically and athletically, earning a place at the prestigious United States Military Academy at West Point. He graduated third in his class in 1951 with a degree in mechanical engineering. Following his commissioning as a second lieutenant, Buzz joined the United States Air Force and served as a fighter pilot during the Korean War. His courage and skill were evident as he flew 66 combat missions, earning the Distinguished Flying Cross for his service. After the war, he pursued advanced education in aeronautics at MIT. There, he completed a doctoral thesis titled Line of Sight Guidance Techniques for Manned Orbital Rendezvous, which would prove crucial to future space missions. His work on orbital mechanics earned him the nickname Dr. Rendezvous, foreshadowing the groundbreaking achievements he would later accomplish with NASA. In 1963, Buzz Aldrin joined NASA as part of Astronaut Group 3, an elite cadre of individuals chosen to lead humanity into the unknown. Unlike many of his contemporaries, Buzz was selected for his scientific expertise rather than test piloting experience. His understanding of orbital mechanics and his innovative approach to problem-solving quickly made him an invaluable asset to the burgeoning space program. His groundbreaking work on spacewalks, known formerly as extravehicular activity or EVA, helped shape NASA's ability to conduct operations outside the confines of a spacecraft. His expertise culminated in the Gemini 12 mission in 1966, where Buzz spent over 5 hours performing a flawless EVA, demonstrating techniques that would later become standard for space exploration. His most iconic moment came on July 20, 1969, as part of the Apollo 11 mission. Alongside Mission Commander Neil Armstrong and Command Module pilot Michael Collins, Buzz participated in humanity's first successful lunar landing. The mission represented the pinnacle of the space race and was a defining moment in human history. After a nerve-wracking descent to the moon's surface, Neil and Buzz landed the lunar module Eagle in the Sea of Tranquility. As Neil took the historic first steps on the moon, Buzz followed moments later, describing the moon landscape as magnificent desolation. His words captured the awe and isolation of being in a place no human had ever ventured before. While Neil Armstrong handled a lot of the public attention, Buzz played an equally crucial role in mission success. He conducted experiments, deployed scientific instruments like the seismometer, and documented the moon's terrain through photographs. His contributions ensured that the mission's scientific and exploratory objectives were fully realized. Buzz's walk on the moon made him the second human to set foot on another celestial body. The iconic image of him standing on the lunar surface, reflected in Buzz's visor, remains one of the most recognizable photographs in history. Following Apollo 11, Buzz became a household name and a global ambassador for space exploration. However, the immense pressure of sudden fame and the lack of follow-up missions left him grappling with personal challenges. Aldrin openly discussed his struggles with depression and alcoholism, demonstrating remarkable courage in overcoming them. His honesty broke barriers, helping to destigmatize mental health issues among high-achieving professionals. With their personal battles behind him, Buzz redirected his focus to advocating for humanity's future in space. He became a passionate proponent of space exploration, especially Mars. His concept of a Mars cycler, a spacecraft designed for efficient travel between Earth and Mars, showcased his forward-thinking approach to interplanetary travel. He authored books, gave lectures, and worked tirelessly to inspire the next generation of explorers. Buzz also played a significant role in fostering international cooperation in space exploration. He firmly believed that humanity's greatest challenges, whether on Earth or in the cosmos, could only be solved through collective effort. Even in his later years, Buzz remained a vital contributor to NASA's vision. He advocated for a return to the moon as a stepping stone to Mars, emphasizing the importance of establishing a sustainable human presence on other worlds. His insights into the technical and logistical challenges of long-duration space missions informed NASA's Artemis program, which aims to send humans back to the moon and eventually to Mars. Through his career, he has shown that curiosity, courage, and resilience are the keys to unlocking the secrets of the universe. And as we'll soon discover, Buzz's fascination with Mars and its mysteries reveal that even the greatest explorers can still encounter surprises that challenge their understanding. Humanity's first step on the moon, the Apollo 11 mission, launched on July 16, 1969, marked the culmination of humanity's relentless pursuit to explore beyond Earth. Decades of science, innovation, political rivalry, and dreams of space exploration converged in this single event, which captured the imagination of millions around the globe. It wasn't just a moment for the United States. It was a milestone for all of humanity, as people worldwide watched live broadcasts of the first human steps on the moon. In the heart of this historic mission were three astronauts: Neil Armstrong, Buzz Aldrin, and Michael Collins. Each played a critical role in ensuring the mission's success, but it was Neil and Buzz who would make history as the first humans to walk on an extraterrestrial body. Together, they spent over 2 hours on the lunar surface conducting experiments and collecting samples that would transform our understanding of the moon. Buzz's role was as vital as it was iconic. He demonstrated remarkable composure and precision in an environment entirely alien to human experience. His movements, careful yet deliberate, were a testament to his astronautical training and innate adaptability. Buzz's famous photograph, standing on the moon with the reflection of Neil and the lunar module in his visor, became one of the most enduring images of the 20th century. Apollo 11 was not merely an achievement for NASA or the United States. It symbolized humanity's ability to transcend barriers amidst the tensions of the Cold War. It was a unifying moment that inspired people across cultural, national, and generational divides. The moon landing embodied the power of scientific teamwork and determination, setting the stage for what humanity could achieve when working toward a shared goal. Beyond its symbolic significance, Apollo 11 was a triumph of science and engineering. The mission conducted groundbreaking experiments and collected data that reshaped our understanding of the moon and its history. One of the most critical tasks for Neil and Buzz was deploying scientific instruments on the lunar surface. Among these was the passive seismic experiment designed to detect moonquakes and provide insights into the moon's internal structure. This experiment laid the foundation for understanding the moon's geology, revealing that it had a crust, mantle, and core much like Earth. Another key experiment was the laser-ranging retroreflector. This device, a set of mirrors, allowed scientists to measure the distance between the Earth and Moon with unprecedented precision. Decades later, this experiment remains functional, enabling researchers to refine our knowledge of lunar orbital mechanics and test Einstein's theory of general relativity. Apollo 11 also focused on collecting lunar material for study. Neil and Buzz gathered 472 pounds of rocks, soil, and core samples, providing an invaluable record of the moon's geological history. These samples revealed a surface dominated by basaltic rocks and regolith formed through millennia of meteoric impacts and volcanic activity. They also contained isotopic evidence that the moon likely formed from a collision between Earth and a Mars-sized body billions of years ago. The insights gained from these experiments extended far beyond the moon. They deepened our understanding of planetary formation and evolution, influencing studies of Earth and other celestial bodies. Apollo 11 set a precedent for science-driven exploration, proving that missions to other worlds could yield discoveries that enrich all fields of knowledge. The cultural impact of Apollo 11 cannot be overstated. For a generation that grew up watching space as an unattainable frontier, the moon landing proved that humanity could overcome even the most challenging challenges. It inspired a wave of innovation, curiosity, and creativity, influencing fields as diverse as technology, art, and education. The mission also served as a rallying point for advancing education and technology. The Apollo program inspired countless young people to pursue careers in science, engineering, and mathematics. From songs celebrating the achievement to science fiction envisioning humanity's future among the stars, Apollo 11 embedded itself deeply in the collective imagination. In addition to the moon landing, it stressed the importance of global collaboration. While the mission was an American achievement, its implications were universal. Leaders from around the world congratulated NASA and the astronauts, recognizing the event as a victory for all humanity. The images of Neil and Buzz standing on the moon, accompanied by messages of goodwill from multiple nations, reinforced the idea that exploration transcends borders. Apollo 11 also marked the beginning of a new era in space exploration. While the immediate aftermath saw a decline in manned lunar missions, the legacy of Apollo inspired the development of long-term programs like the International Space Station and plans for Mars exploration. Buzz himself would go on to become a leading advocate for human missions to Mars, continuing the legacy of Apollo as a stepping stone to even greater achievements. Buzz Aldrin's vision for humanity's future has always been grounded in exploration. After making history with Apollo 11, he has turned his focus to a new frontier, Mars. Even now, at the age of 94, Buzz still firmly believes that Mars represents the next logical step for human space exploration. He has spent decades advocating for a robust plan to send humans to the Red Planet. But now, due to this very fascination, Buzz is ready to reveal what NASA has been hiding for decades. But we will get to that in a bit. One of Buzz's most notable contributions to interplanetary travel is his concept of the Mars Cycler, a transportation system designed to shuttle astronauts between Earth and Mars efficiently. The Cycler, envisioned as a spacecraft following a continuous orbit between the two planets, could serve as a reusable vehicle, reducing costs and increasing mission feasibility. Buzz's detailed design leverages his expertise in orbital mechanics, combining scientific rigor with an ambitious vision for humanity's future. His proposals extend beyond technology to include long-term strategies for colonization. Buzz has argued that Mars offers an unparalleled opportunity for humanity to establish a self-sustaining presence beyond Earth by building bases, cultivating resources, and eventually terraforming the planet. He envisions a future where humans not only visit Mars but actually thrive there. Unlike the Moon, Mars has an atmosphere, albeit thin, and evidence of water ice, making it a more promising candidate for sustained human habitation. Aldrin has often described Mars as the ultimate test of humanity's ability to adapt, innovate, and collaborate in the face of challenges. Mars exploration presents both enormous challenges and transformative technological opportunities. Hurdles such as developing life support systems and radiation shielding are significant, but Buzz views them as surmountable with innovation and commitment. For him, the opportunity to unlock Mars's secrets, such as the possibility of past or present life, makes the effort worthwhile. Buzz has emphasized that Mars exploration is not just about science. It is about survival. He sees Mars as a potential insurance policy for humanity in case of catastrophic events on Earth. By establishing a presence on another planet, humanity could ensure its continuity and open the door to further solar system exploration. While Mars itself has captured Buzz's imagination, he has also expressed significant interest in its two small moons, Phobos and Deimos. These potato-shaped satellites, with their low gravity and proximity to Mars, are ideal candidates for exploration and development. The discovery of the Phobos monolith has captivated the imagination of many. The mysteries of the cosmos have always intrigued humanity, but few discoveries have sparked as much speculation as the enigmatic structure found on Phobos, one of Mars's two moons, known as the Phobos monolith. This rectangular anomaly first came to light through images captured by NASA's Mars Global Surveyor probe in the late 1990s. The images revealed a feature on Phobos's surface that appeared strikingly different from its surrounding terrain, a large rectangular object casting a prominent shadow on the moon's rocky surface. Phobos, like its sibling Deimos, is a small, irregularly shaped satellite resembling a lumpy potato more than a traditional spherical moon, measuring just 14 miles across at its widest point. Phobos orbits Mars at a distance of about 3,700 miles, completing its circuit around the planet every 7 hours. Despite its diminutive size and proximity to Mars, Phobos has managed to maintain an air of mystery, and the monolith has only added to its intrigue. When the monolith was first identified, scientists and researchers examined the images to determine whether the formation was a natural feature or something else unusual. NASA's official stance emphasized that the structure was likely to be a naturally occurring boulder. However, the unusual shape and solitary prominence of the feature led many to question whether it could truly be a simple geological formation. Its clean edges and contrast to the chaotic, cratered surface of Phobos made it appear almost artificial, sparking curiosity both within the scientific community and among the public. The monolith's location also added to its mystique. Phobos is thought to be composed of carbonaceous chondrites, a type of material found in primitive asteroids, and its surface is covered with a thick layer of dust and regolith. In such an environment, a singular, towering structure stands out dramatically. Coupled with Phobos's peculiar orbital behavior and its proximity to Mars, the monolith became a focal point for discussions about the moon's origins and the broader mysteries of the Martian system. From the outset, scientists sought to provide rational explanations for the Phobos monolith. Most agreed that it was likely a large boulder that had been ejected from the Martian surface or another celestial body during an ancient collision. Over time, the boulder could have landed on Phobos and settled in its current position. Erosion and impact processes, combined with the moon's weak gravity, may have contributed to its distinct shape. Despite these plausible scientific theories, the monolith's unique appearance fueled public fascination. The idea of an artificial structure on Phobos gained traction, particularly among proponents of extraterrestrial theories. Media outlets and forums began circulating the image widely, often accompanied by speculation about its origin and purpose. The monolith quickly became a symbol of the unknown, an object that seemed to defy easy classification, adding to the intrigue. Phobos itself has long been a source of mystery. Unlike the Moon, which has a relatively stable orbit, Phobos is gradually spiraling closer to Mars and is expected to either crash into the planet or break apart in the distant future. Its irregular shape and low density have led some to hypothesize that Phobos might be a captured asteroid or even a rubble pile held together by weak gravity. These unresolved questions about Phobos's nature amplified interest in the monolith, suggesting that it could hold clues about the Moon's formation and history. The Phobos monolith has been the subject of numerous ranging theories, from the plausible to the extraordinary. On one end of the spectrum are the scientific interpretations that see the monolith as a natural formation. Geologists point out that similar structures, such as angular boulders, have been observed on Earth and other celestial bodies. The sharp edges and rectangular appearance of the monolith could be the result of fracturing, impact processes, or erosion. On the other end of the spectrum are theories suggesting that the monolith might be artificial in origin. These ideas are rooted in the unusual characteristics of the feature, which seems out of place on the chaotic surface of Phobos. Over the years, the Moon has been associated with several enigmatic phenomena, including unexplained anomalies in its orbit and peculiar surface features. Some early astronomers even hypothesized that Phobos might be hollow, an idea later debunked but still intriguing. Be that as it may, the Phobos monolith, with its striking appearance and enigmatic nature, captures the imagination of all who study it. While scientific explanations point to a natural origin, the structure continues to evoke questions that challenge our understanding of the solar system. For years, experts like Buzz have studied Phobos and its features, underscoring the enduring intrigue of this tiny Martian moon. The past awaits finally at 94. Buzz reveals what NASA was hiding for decades, a secret that could reshape how we look at history and the universe as a whole. Buzz is no stranger to the mysteries of space, and for decades he has been a central figure in discussions about the cosmos. However, according to a source close to the legendary astronaut, he revealed something extraordinary in a private conversation during a quiet dinner with a trusted friend away from the public eye. He allegedly shared shocking details about NASA's knowledge of past civilizations and what might be hidden on Phobos. The conversation, as recounted by the source, began innocently over the course of the meal. The topic turned to space exploration as it often did in Buzz's presence. The friend, intrigued by his long-standing fascination with Mars and its moons, pressed him about the Phobos monolith. This peculiar structure, visible in NASA's own images, has been a topic of curiosity for years. Buzz, known for his openness about space exploration, allegedly revealed something amazing. They kept this secret, Buzz is said to have remarked, but NASA has known about the ancient civilizations linked to Phobos for decades. According to the source, Buzz claimed that the Phobos monolith isn't just a natural anomaly. Instead, he suggested it is, as many suspected, evidence of a once-thriving civilization possibly even linked to Mars. This wasn't wild speculation on Buzz's part either. He has reportedly hinted that NASA has classified files containing data and images that lend credibility to this theory. Buzz allegedly spoke about how scientists at NASA and other international space agencies have debated the origin of the monolith since its discovery. While the public story focuses on natural geological explanations, the private discussions, as described by Buzz, are far more speculative and far more intriguing. He reportedly suggested that the shape, isolation, and prominence of the monolith are unlikely to be the result of random natural processes. It's almost as if it's meant to be seen, Buzz is said to have remarked. The source also claimed that Buzz hinted at the existence of additional classified information, files so sensitive that only a handful of people have ever seen them. These files, he reportedly said, go far beyond the Phobos monolith, containing evidence of other unexplained structures and phenomena in the solar system. According to Buzz's alleged admission, these documents paint a picture of a universe far more complex and inhabited than the public has been led to believe. The idea that NASA might be withholding information about Phobos and its potential connection to ancient civilizations raises obvious questions. Why would such discoveries be kept from the public? According to Buzz's account, the reasons are multifaceted. For one, confirming the existence of extraterrestrial civilizations, or even the remnants of them, would be a world-altering revelation. The implications for science, religion, and geopolitics would be profound, and governments might prefer to control the portrayal. Another reason for secrecy could be the lack of concrete evidence. While the Phobos monolith and other anomalies might strongly suggest non-natural origins, definitive proof is still elusive. In such cases, NASA and other agencies might choose to avoid public speculation until more data can be collected. However, if Buzz's claims about classified files are true, it raises the possibility that some of this proof already exists, hidden from public view. There's also the potential issue of national security. If ancient structures or artifacts on Phobos or elsewhere contain advanced technology, governments would likely want to study them in secret to assess any potential threats or advantages. The conversation reportedly took an even more startling turn when Buzz hinted that the Phobos monolith might be just the tip of the iceberg. He allegedly mentioned that there are other monoliths or unexplained structures elsewhere in the solar system, including on Mars itself. These structures, if connected, could suggest a vast ancient network of extraterrestrial activity. If Buzz's alleged revelations are true, they could have profound implications for our understanding of the universe and humanity's place within it. The idea that ancient civilizations might have existed in the solar system is no longer confined to science fiction. It is a possibility that demands serious consideration in light of these revelations. Buzz Aldrin has reportedly expressed concern over the implications of what might be uncovered on Phobos and beyond. According to the source, he believes that Elon Musk, with his ambitious plans for Mars exploration through SpaceX, might uncover secrets that humanity is not yet prepared to face. In a private discussion, Buzz is said to have urged Elon to approach Phobos with caution, warning that the monolith and its potential connections to ancient civilizations might hold answers but also risks that could reshape our understanding of the universe. For Buzz, the challenge is not just about exploration but about ensuring that humanity is ready for the profound truths that might lie ahead. So, what do you think this structure is? Let us know in the comments.